Every physical quantity, whether it's speed, force, or energy, is made up of basic quantities like length, mass, and time. The powers to which these base quantities are raised in an expression are called its dimensions. Dimensions help us understand the structure and nature of any physical quantity. We represent the 7 fundamental quantities using these symbols: length, L, mass, M, time, T, electric current, A, thermodynamic temperature, K, amount of substance, mole, luminous intensity, CB. In dimensional expressions, we only write the quantities that are involved. So if a quantity depends only on mass, length, and time, we use just N, L, and T. Let's take a few examples. Velocity equals distance divided by time, dimensions. L divided by T equals L times T to the power minus 1. Acceleration equals velocity divided by time. L divided by T squared equals L times T to the power minus 2. Force equals mass multiplied by acceleration, M multiplied by L times T to the power minus 2. Final dimensional form equals M times L times T to the power minus 2. Work equals force multiplied by displacement, M times L times T to the power minus 2, multiplied by L. Final form equals M times L squared times T to the power minus 2. These expressions show us how a quantity is built from base quantities. To write dimensions, we use dimensional notation using powers of base symbols. Examples: velocity, m to the power 0, L, t to the power minus 1. Force, M(L), t to the power minus 2. Energy, M(L²T) to the power minus 2. We often write these as velocity, m to the power 0 times L times t to the power minus 1. Force, m times L times t to the power minus 2. This helps represent the nature, not the unit, of a physical quantity. Dimensions are useful because they let us check correctness of equations, convert from one system of units to another, derive relations among quantities, understand how different quantities are related. For example, if an equation has mismatched dimensions on either side, it must be wrong. Now that we understand what dimensions are and how they describe physical quantities, let's see how we use them to write complete expressions. Up next, dimensional formulae and dimensional equations.